Hi, everyone. I'm Ash Davies. I'm talking about using mocks in unit tests today. Most of my talks are usually born from frustration or getting angry about something in the project. And this was just seeing mocks being used in ways they really probably shouldn't. So I'm going to kind of go over some learnings about this and sort of why maybe you can think about taking a different direction or different approaches to this. The slides will be available online afterwards. My website is on the bottom left there, a bit obscured, but you can go check that out later. So this kind of always comes from legacy code, and it can be pretty tough to know where to start with on legacy projects. We've all had to work with legacy code, inherited code that you've joined the project on. And how do we kind of reliably work with this code? Because nothing is permanent, and at some point you're going to have to change something. This code doesn't live in perpetuity, and that can mean adding a feature, fixing a bug, or refactoring some code. But how can you be confident about these changes? How can you be confident that you're making changes that are not going to break your application? Well, the key here is obviously testing. So making sure you have adequate code coverage, not paying attention to the metric, it's a useless metric, but making sure you have adequate code coverage can give you confidence in refactoring and making changes. Michael Feathers described this as cover and modify instead of edit and pray. So writing test code at the same time as production code can give you better perspective over edge cases. It's really good for awareness of what your code is doing. And poor code is often synonymous with poor architecture. So it can really highlight problems in your architecture and in your code design if you're finding it difficult to test. And further, confidence in your tests means confidence in your code and confidence in your refactoring. So it can put you in a better position. And there's documentation. So the best kind of documentation is actually testing, because this gives you insight into what was the thought process when you were writing this code in the first place. It's less likely to kind of expire as quickly as written documentation. And it's going to give you a better idea of the domain behavior. And well-written tests provide robust protection against regressions. So it's not really my goal to kind of convince you to write tests. We should already be in that situation, but more to kind of help you write better tests. And if you're not interested in writing tests, there's a great talk about composed text in the other room. So I'm going to focusing on unit testing. Actually, people leaving. I'm going to focus on unit testing here because this is sort of what's more important to me, and it's kind of fundamental to the process. But it's important to remember that there is a comprehensive test pyramid that you should build for your applications. This includes UI tests, instrumentation tests, integration tests, end-to-end tests, monkey testing, smoke testing, and just any testing you can kind of get in there. But a good test suite is comprehensive, so you're going to have different layers of different tests. So fixing unit tests can sometimes feel like navigating a minefield in the dark with a blindfold. It's difficult to follow the history, and it's difficult to understand. Tests can sometimes also be difficult to run and difficult to interpret. So what's the cause of this? It's anti-patterns and code smell. It's not until we start writing more unit tests or refactoring unit tests that we kind of find these difficulties and find these problems that we are getting because of poorly structured code, for example. There are some strategies around this. Some schools of extreme programming is one is test-driven development. You may have already heard about this. This is where you're writing code, writing tests before actually writing the production code. So you make a test assertion that fails, and then you write the code that makes it succeed. These sort of extreme coding practices are really good for practicing your skills, but might not always be useful to do day-to-day for production. I always like to add this as well. So Git blame will always out you as the murderer in this case. And it's just painfully true. The amount of times I've had a bug, like, oh God, there's such terrible code, and the Git blame is like, oh. I'll go back to his. So one of the guiding principles of Kotlin is making it easier to write good code. These kind of helpful little things that it push you in the right way. Sure, you can still write bad code if you want to, but it sort of makes it easier for you to actually write better code. And one of the principal tenets of this, I feel, is the concept of mutability. So what is mutability and what are the risks of mutation? So take this contrived example. It's impure, it's in-place mutations, and has a non-deterministic state. It's hard to predict. So it's actually taking in, I mean, no one in the right mind would write this function, but just take it as an example. It's taking in a mutable list, and it's actually editing it in place. Sure, maybe there might be performance things to think about here, but if the idea is that every time you call this function, it's going to mutate the state around it, and you're going to get a different result each time. Whereas a pure function should be giving you the same result every time with the same input. An example of this as well is the Java date class. So this actually allows you to modify its upstream. So then if you provide it to consumers, then change the date and not be predictable. So this is a shared mutable state, and it causes race conditions, non-deterministic behavior. We can use things to kind of get around this. So, the thread-safe confinement, mutexes, semaphores. These are all kind of help mitigate these dangers. But the best approach really is just using good architecture in the first place. So on the other side of mutability, we have, of course, immutability. So building a unidirectional data flow, if you might have heard this already, is really helpful to kind of keeping your data in check. It makes sure that your flow of states is predictable, and it's easier to find bugs and even easier to predict application state. A really nice thing about Kotlin here is that it provides you with this kind of difference between a list and a mutable list. Now, these may be backed by Java implementations under the hood, but these interfaces don't actually provide you with mutations. So it's just kind of gently pushing you in the right direction. Another thing I really like about IntelliJ is this little underlined thing you have for var classes, which are var values which are mutable. And I don't know about you, but seeing these little underlined bits in my code, it just looks annoying. It bugs me. It kind of gets under my skin. And that's the really nice thing about this language in the IDE. It's like it doesn't stop you from doing these things, but it just annoys you enough that you don't want to do it. So there's a subconscious encouragement. Another thing is, by default, Kotlin classes are final. They can't be inherited from. This was by design. It then made it quite difficult for everyone to migrate from Java to Kotlin, but there was a reason for that. You can, of course, open class, make it open for inheritance if you are so inclined. There's also the open compiler plugin. This is for unit testing for situations where you need to work with open classes. Spring is a good example of this. I wouldn't recommend using it for this case, but it's there if you need to know about it. Back to anti-patterns and code smell. So the biggest problem with refactoring is often dependencies. I'm going to jump to our favorite example. If you've ever had to work with Dagger, you'll know this from the documentation. So the most common method of refactoring is to invert control, which requires the caller to provide the dependencies. Enjoyable use of thermosiphon here. So let's, it's really hard to see the code there, sorry about that. But the code in yellow is what was taken out and what was added. So reducing the dependency scope by narrowing the inheritance there kind of makes it a bit easier to manage. The dependencies are injected into the class constructor, and this is kind of a seam we can introduce to start testing. And this is what we're doing to make testing easier, is by providing these dependencies in the constructor. So if we're writing unit tests, they should run in milliseconds, not seconds. They should be really running really quickly, because you're going to have a really comprehensive suite of lots and lots of tests, or at least hopefully. So if you've got some expensive dependencies which are kind of taking a lot of time to instantiate, or maybe performing I/O operations, these can be replaced through kind of cheaper implementations that allow your unit tests to run a bit quicker. It's not just about performance as well, though. Tests should be idempotent. Yeah, I can't say this word. Idempotent. So things like disk operations that can be stateful, this can lead to unreliability in different test results. So you want to kind of avoid that. And you might just have something that's error prone and shouldn't be used really. So you want to have a test unit in isolation. So this introduces the concept of test doubles and basically what we're going to revolve around today. Test doubles are kind of a common technique to replace dependencies, allowing your test to run in isolation and to get a better granularity of control. The crux of this talk, mocks. So mocks are a type of test double that allow you to specify expectations and validate interactions. It's very tempting to go with this approach to validate interactions from your tests, but it's more beneficial to actually validate the resulting state because it can really be difficult to kind of know what's happening internally inside of a class, and your unit test really shouldn't be concerned with that. It should just be validating the resulting state. So Mockito is a popular framework for working with mocks on Java. It's not my intention to poop on this library. It's actually really powerful and has its use cases. I'm just here to advocate against alternatives. Advocate for alternatives. So providing this now class with mocks, and we want to see if this works. We cross our fingers, we pray to the gods, and we throw salt over our shoulder, sacrifice a goat, all the things. And of course, it's going to fail because this mock doesn't do anything. It's not been configured to perform any behavior. So what do? We add this additional behavior. And this is really quite interesting because this is an extensive API for configuring mocks. And Mockito actually does really provide a good DSL for building mocks. And there's really complex and iterative behavior. But then, we have something else for building classes, a very concise DSL for building classes called Kotlin. So Mockito is a really powerful tool, but it can be really easy to kind of shoot yourself in the foot or in the face. It can be really difficult, and how am I supposed to set up this mock? And there's different entry points as well. This BDD style syntax, and which one should I use? Which one is better? So there's also kind of some foot guns as well that this is actually going to be the actual invocation when you're setting up your mock. So you'll often not discover this behavior because maybe it just goes unnoticed. But yeah, if it has no implementation, then it's actually going to return null. So things like this, where you're calling get on a list of strings, it's going to throw an index out of bound exception because, well, the list doesn't have anything there. So this is actually a documented gotcha. There's also such a thing as API sensitivity. So creating runtime dependencies and creating these interactions with things, you're not going to have the same level of reliability as you would if you handwrite the code. Say, for example, you add a new function, and then the mock is going to continue to work as it was before without any change. And maybe you might argue that's desired function, but I think if you modify an interface, it should break other things. So it's not the fault of the library here, but it is a source of bugs. So, for example, we didn't actually mock out the vararg sequence here. So we're only saying, only expect an invocation with 2 arguments, but it's a vararg. It should be dynamic. It should be able to provide multiple classes. But this is going to be false because we only mocked for the second one. Another one I've seen is that it might be tempting to mock data classes. Just don't, please. Another one is default answers. So it's not going to have a default answer for this because, well, it's just not configured properly. By default, Mockito returns null and all methods without stubbing. Unexpected nulls can throw deep in your execution chain, and it can really difficult to find the actual execution stack. The option here is to use default answer, where you can actually have your mock return another mock underneath the hood. So then you've got mocks returning mocks returning mocks returning mocks. There's lots of different options for this. You've got call real methods, deep stubs, defaults, mocks, selves, smart nulls. And I implore you, if you are using these, seek help. Not just as a support thing, but you've probably seen some things. Another one is type safety. So Mockito Kotlin provides a bit more reified type safety, but because Mockito is actually just using Java under the hood, there's a lot of API kind of gotchas that can be really unexpected. So the answer here is unknown because, well, type is erased. So in your actual Lambda, the way you've got the answer, you can provide any sort of thing, and then it'll just throw at runtime because there's no type checking on it. And then, there's the other thing to question is that we've put all this extra work into replacing our real implementations with mocks so that we can get this performance improvement. But mocks themselves are a performance nightmare. They are, if you look into how they're kind of generated, it's really quite wacky. There was a talk earlier from Sam who briefly covered on using proxies in Java. And there's a similar sort of approach. So it's like runtime code generation and bytecode manipulation and reflection going on here, which are like prohibitively expensive operations, which you kind of want to avoid in unit tests that you want to be going, pretty fast. Often seen this used for performance improvements. It's anecdotal. I'm not sure if it actually improves performance, but it's in the documentation to actually produce a mutable state between tests. The thing sort of bugs me most about here is the dynamic mutability of this. Like, if you've got a mock set up in your class instance, then you're kind of mutating that. It's really hard to predict what state that mock is currently in, what's going on there. And dynamic mutability, as I alluded to earlier, is the root of all evil. We want to make sure that everything is immutable. So dynamic mutability. This is my cat, Kotlin. Yeah, we call him Cotty, actually. But yeah, framework-generated mocks introduce like a shared mutable state, which is like not good for reliability. Cotty knows it's wrong, and so should you. So predictability is an underrated metric, and it's hard to quantify. What are the kind of costs of this? What are the downsides? I mean, you want to make sure that your code is predictable and can be understood easily. One of the core things here is the same with legacy code, is that there's an increased learning curve. When you're bringing on new colleagues or people new onto the team or even people from other teams onto your team, it's going to take longer for them to understand what on earth is going on in this mock or what this unit test is doing. Adds time to peer review. Hard to review code is going to be kind of hard, going to take longer to review, and it's going to be harder for you to get things merged. So that's actually going to have a slowdown on your feature development. I'm not going to apologize for the memes here. Yeah, PRs are running open, and developers get sad. This unpredictability as well means you cannot predict the edge cases. So there's risks of bugs, regressions, and things can go wrong. It's kind of difficult to work with. And ultimately, it slows down feature development. Technical debt must be eventually repaid. And this is going to slow down feature delivery. This is the best argument you can use for product managers or people who are more interested in features, because this sort of stuff will slow down development. And quite interesting as well, if you maybe write the code on Friday and you think it's beautiful and come back to it on Monday, and then, yeah. So it's not just junior developers or new team members that are going to have difficulties here in understanding the code. It's actually you next week, tomorrow, when you come back from holiday. I don't know about you, but whenever I come back from holiday, I completely forget about the world of Android. And it's like starting to be a beginner again. Which is kind of enjoyable, actually. So there's a really good article from Google testing on the toilet. This was a series of blog articles that they created where it was like a printout that they would actually post to toilet cubicles so that you could read whilst on the toilet. But this one is really quite interesting. It's the idea of not mocking classes you don't own, because mock classes may change in ways you don't expect. Third-party classes may change in ways you don't expect. So those mocks are going to be then changed, and you're going to be oblivious to these invisible changes. But I would like to take this one step further, because it's not just exclusive to classes you don't own, but you don't own your code. Developers might be kind of egotistical, or I mean, that's a hard thing to say, but like, it's important to remember that when you write your code, and then from the moment you push it, it's no longer your code, it belongs to your team. And it's important for you to make sure that your team can understand it, because you're working with these people. You want to make their lives easier, because eventually they'll do the same for you. And be considerate, and pay it forward. Be the nice person in your team so that it's a better team for everybody. Again, not pooping on Mockito here. It's a great tool, has extensive features, powerful DSL. I just feel that it's overused. The idea that you're verifying interaction is kind of error-prone in itself. It doesn't matter if the invocation is correct, if the outcome is wrong. At some point, you're testing the language. Like, I've seen some mocks where they're setting up the mock, and then there's an assertion against this function that you just created in the mock. And it's like, you're not testing your code here, you're testing the mock. This point deserves its own talk, but I'm going to kind of gloss over from that. So let's assume that we're working with a legacy code base, and we've got mocks everywhere. And well, what do we do now? Well, there's another option. So we've got stubs. You may have already encountered stubs. These are a type of test double it's a really simple implementation that's designed only to make your test compile. So it'll just kind of return default answers. And it'll be really simple and easy to understand. It's meant to be simple. There's no verification or reproducing logic here, just returning default behaviors. But just looking over that, even if you can't see the bright yellow code, or is it green? I'm colorblind. You can understand what's going on. Stubs implementations are a bit more idiomatic because you're using Kotlin as a first language feature, so you can actually benefit from having these nice features. So here, for example, we've got the functional interface, so you could just provide a stub as in a very short snippet. Quite nice. And classes declared in Kotlin are sensitive to API changes. So if you add this new function to it, you're going to have to add that to the stub as well. And this is actually a desired behavior. If you change your interface, you should actually have to change the functionality. It's not an advertisement for Coke. I just had it on hand. But what if you need a bit more control over what's going on? This is where we kind of come into the concept of fakes. You still want to verify something, or you want to verify the outcome or get access to it, but you want to keep this implementation really simple. It's actually really easy to do. You can be creative. You can use idiomatic Kotlin code to provide the implementation that you require. Some might argue that it's a bit of an overhead, but actually I think it gives you much more control and better readability and better structure to your code. And we can then use the magic of Kotlin interface delegation as well to then wrap any existing behaviors or kind of delegate to other classes and provide some additional behavior that if you need to validate what drinks there were in this class, for example. So you have full control of the fake behavior that you can decide, OK, what it is I need to actually test. And when you've been then a bit more explicit about what it is I'm testing, it's much easier to read and understand if you're coming as a new developer to that code, to that unit test, to see what the intention here. But there's the authoring thing, and because you need to sort of implement this fake behavior at the same time as the actual kind of test, who is responsible for writing these fakes? Who's responsible for creating these fakes? Well, that's you, and that's actually a really good thing, because if you're writing the test implementation at the same time as the actual real production implementation, you are the person most qualified to give this logic, to give this implementation behavior. So you alone, well, if you're writing this code, then yeah, you're best qualified, because you still are in the context when you wrote the production implementation. There are a lot of SDK test artifacts, but not as many as there should do. So if you're an author writing a library, I employ you to provide test artifacts. There are these test libraries that are great to use as well, mostly from the JetBrains team. Thanks. One thing I'd like to mention as well is like when you're working with test fakes, you have the option as well of providing implementations that could actually be useful for other production environments. So consider like just an in-memory test implementation. Really quite straightforward. It maybe looks more complicated than it actually is. But this is just an in-memory map storage of the stock of the coffee that's been going on. This is not just useful for tests, but it's useful for production environments, maybe, or development environments where you want to actually kind of then work testing with physical devices, or if you have a QA team that you want to provide different versions for. Or maybe you want to work in cache environments where you have like low network availability, and you want to be able to provide alternative interfaces so you can work locally instead of actually having network access. But we don't always have the luxury of working with good code. Yeah. I always kind of like to refer back to this illustration originally from, I think, the Voda team. And this is on the idea of interface segregation principle. Not to bang on about solid design principles, that's so 1990. But interface segregation is really quite a useful tool. And this is the concept of introducing seams. This is well documented in the Working Effectively with Legacy Code book with Michael Feathers. And this is a concept of introducing seams between implementations of classes. I'll go to further detail about this, but what you can do to introduce seams is obviously different mechanisms. You could go for the pre-processing route, like for example, Kotlin symbol processing or compiler plugins. Fun fact, Compose itself, as a compiler plugin, actually modifies your code to provide this composition things. But I wouldn't really go through this route. It's a bit overkill. There's also class path. So when you actually run a Java application, you're providing a class path to the implementations of your classes, and you could simply just override that. We've all used class path before. Maybe not fully aware of it, but yeah, this is the same sort of deal. You can just provide a different version. Again, overkill. I wouldn't go through this route. It's simply better to refactor. Yeah. So object refactoring is probably the most modern, reliable way of introducing these test seams. And the nice thing about IntelliJ is that it has all these different ways of introducing these things and helping you with refactoring. So you can get started with this very quickly. And a shameless self-plug here. I'm going to give a talk about everything as an API. I think it's really important to consider that when you're writing code, it's not just yourself is going to be using it. It's your consumers, it's your team. So if you take this consideration to think that, well, if I consider all of my code as an API, I'm making better API decisions. You're maybe not just producing an SDK or something, but this is intentional thought about what you're producing. But like many frameworks, Android has a long and rich, colorful history, and whilst there have been great advances in Jetpack, Android X, and Project Mainline, there are still some parts of the application that you're working with that might still be a little bit historic and have some legacy code, for example. So this is a great example of a violation of interface segregation, because you've got a context here which is doing a lot of things, and they're not related to each other. And if you wanted to, say, provide a mock context, it's damn near impossible, because you would have to implement all these different things that just cannot be done. So this is, I understand, one of the primary reasons to introduce a mock. It's referred to as a God object, with a large number of distinct types and unrelated methods. So since they command so much, it's really difficult to provide an alternative implementation. Fun fact, I found out during this that the antithesis of this, the opposite of a God object, is ravioli code. Apparently the Italians had it right all along. It's important to consider this is not a gold standard replacement. It's just another style of coding. There's ravioli code, there's pizza code, there's pasta code. It's quite interesting. So to recap, mocks are designed as an API to verify interactions. There's a lot of black magic voodoo going on under the hood. Java reflection, proxying interfaces, and it's kind of difficult to manage. You've got stubs that perform the bare minimum to allow your test to pass, and then you've got fakes, which are hand-coded, maybe take a bit of extra time, but that time you're invested into the longevity of your code is going to be worth it in the long run. So to conclude, don't mock classes you don't own. Don't mock classes you do own. Don't mock classes, or except maybe context. And I'm going to leave you with this quote that I always like to add. Everything existing that is born without weakness prolongs itself out of weakness and dies by chance. Mash that up. But this quote is often paraphrased in the computing context, with every line of code is written without reason, maintained out of weakness, and deleted by chance. Thanks.